Hello students, today we'll be starting a new chapter called Arithmetic Progression, or as we're going to refer to it now on as AP. Now AP is a chapter in which we will simply look at a sequence, a series of numbers and their properties. You might have seen such things in IQ tests, in quizzes when you were younger. That is what we are talking about, and that is what we're analyzing. So an AP is simply a series of numbers that follows a pattern. For example, 1, 3, 5, 7 and 9. These 5 numbers are following a certain pattern, and if you look closely, the pattern is that when I do 1 plus 2, I get to 3. When I do 3 plus 2, I get to 5. 5 plus 2, I get to 7. And 7 plus 2, I get to 9. This is the property of an AP, where two consecutive terms are always separated by the same difference. And this is what we'll be studying, series like these, and what are their properties. Particularly two types of things. The first type of thing we'll study is finding the nth term of an AP, where they'll give you an AP and ask you find the 10th term, 20th, 50th, 100th, so on and so forth. And similarly, they can ask you, I can add up all these numbers to get a sum. So we will do the sum to n terms of an AP, where again you'll have an AP and they'll ask you what is the sum of the first 10, 15, 20, 30, so on and so forth terms. So let's first get started with the nth term of an AP. So we're now looking at the nth term of an AP. Before we do that, let's understand some basics of every single AP. So if I bring back the AP I had last time, 1, 3, 5, 7 and 9. This was my AP. Now let's start understanding from the beginning. The first term of your AP, in this case the number 1, is literally called your first term, and it is denoted by the symbol A. So we will say that the first term of this AP, A, is equal to 1. Second, now if you observe, 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2, and 9 minus 7 is also 2. As we can see, we are getting a common number, and this is known as the common difference, denoted by the letter D, and it is equal to, in this particular case, 2. Common difference is simply the difference between any two successive terms with the later term minus the earlier term. These are your two most critical things that define your AP. If you have your first term and you know what your common difference is, you can find any number in the AP through the nth term formula. So let's look at the nth term formula. It is defined as A subscript n. So A subscript n, where n is your term that you want to find. So if I say A10, that means you want to find the 10th term of the AP. So we say that An is equal to A, which is your first term, plus brackets n minus 1 into D, multiplied by your common difference. This is your nth term formula, and using this you can find any term of an AP. The benefit of this is when you want to find a very large term, a term like the 100th term of an AP, writing out the AP will be very difficult. So that is why we use this formula. So we don't always need to have an increasing AP, the 1, 3, 5, 7, 9. APs can also be of the form where it's decreasing. So for example, 10, 8, 6, 4 and 2. Clearly one can see that this is decreasing every time, and it's decreasing by 10 going to 8 minus 2, 8 going to 6 minus 2, 6 going to 4 minus 2, 4 going to 2 minus 2. So this is one type of AP you can have. Also, we can have an AP with fractions being part of it. So what about this AP? 1, 1.5, 2, 2.5, 3. Clearly, the difference between 1.5 and 1 is half. The difference between 2 and 1.5, half. 2 and 2.5, half. 3 and 2.5, half. So like this, an AP, any AP is allowed as long as the difference between the consecutive terms remains the same, whether it's negative, whether it's a fraction, anything. So now that we know that an AP can be of any form, let's look at some of the work that we can do with them. So now let's look at some of the applications of the nth term formula. I'm just going to write it down. A of n is equal to A, which is your first term, plus n minus 1, n the nth term we want to find, into D, your common difference. So the very first type of question is just a straightforward. They will give you your AP and ask you to find some term. So let's say that it says this is your AP and we say find the 20th term. So what we need to do is identify all three things in our formula. So what is our first term? Is obviously 1. So A is equal to 1. For the common difference, we will pick any two consecutive terms and do the later term minus the earlier term. So if I take 7 and 5, my common difference is 7 minus 5 equal to 2, which is your common difference. And obviously, we've been asked to find the 20th term, which means n is equal to 20. So my 20th term, A20, will be equal to 1 plus 20 for n minus 1 into D, which is 2, which is 1 plus 19 into 2, which will be 1 plus 38, which is equal to 39. So we can say that the 20th term of this AP will be 39, and you can write it out for yourselves and see that you will be getting the same answer. Another type of question is one in which you will be given a different set of things out of all of the things here and be asked to find the missing one. For example, the question could be, what term of the AP 1, 4, 7, 10, ... is 40. So in this question, they've given you A of n and they're asking you to find what term of the AP, meaning they're asking you to find n. So once again, A is simply equal to 1, D will be equal to 10 minus 7, 3, an is 40, you want to find n. So we'll plug it into our formula. 40 is equal to 1 plus n minus 1, since that is what we don't know, into D, which is 3, which implies shifting the 1, subtracting it. 39 is equal to n minus 1 into 3. Cross multiply, it will become 39 divided by 3, which is 13 is equal to n minus 1, which means shifting 1 to the other side again, n is equal to 14. So they gave you some information, 3 out of the 4, and asked you to find the missing thing, which was what term of the AP. We got 14. Again, you can write this AP out and see for yourself what is the answer. A slightly harder problem is one in which they'll ask you to find a couple of things from the formula. For example, the question could be, find the AP whose 10th term is 16 and 13th term is 22. So what we will do is, obviously we don't know what our A is and we don't know what our D is. We have N and AN for a couple of terms. So we will simply create the formulas for that. So A10 is equal to A plus 10 minus 1 into D, which is equal to, we are told that our 10th term is 16. This simply means that A plus 9D is equal to 16. And similarly, A13 is equal to A plus 13 minus 1 into D. 13 we know, A13 is 22. So this means that A plus 12D is equal to 22. Now if you carefully observe, these are two linear equations in two variables. We can solve it using linear equation methods. So I am going to say, let this be 1, this be 2. If I do 2 minus 1, A minus A will get cancelled. 12D minus 9D will be left with 3D. 22 minus 16 will be left with 6. So we are getting that D is equal to 2. Now substituting back into any one of the equations, let's say into 1, we will get A plus 9 into 2 is equal to 16. This is nothing but A plus 18 is equal to 16, which means A is equal to minus 2. So we have our first term, we have our common difference, we can form our AP. A is equal to negative 2, D is equal to 2. This means my AP is minus 2, 0, 2, 4, 6, dot, dot, dot. So like this, when nth term questions come, you simply need to focus on the formula, plug in your variables and then solve. Now let's look at the sum of an AP. As we said at the beginning of this topic, that an AP focuses on two things, finding the nth term and now finding the sum. So assuming that once again we have our AP that we had at the start, 13579, the sum of an AP, the formula is Sn, where again n represents the number of terms till which you want to calculate it, is equal to n by 2, number of terms divided by 2, multiplied by, we open the bracket, 2a, 2 times your first term, plus another bracket opened, n minus 1, close the bracket, multiplied by common difference, and then finally close the outer bracket. So n by 2 into 2a plus n minus 1 d. This is the formula for sum till n terms. While it looks a little bit complicated, it is far easier to learn this formula than to actually try to find the sum of 100 terms. Obviously that will take too much time. Now if you observe one thing, in this particular formula, I can play with it a little bit. So look at the inner bracket. It is 2a plus n minus 1d. I can break this 2a to be a plus n minus 1d. Now a plus n minus 1d is simply your nth term formula. So we can see that my formula can be replaced with Sn is equal to n by 2 into a plus an, or the last term from the n number of terms. So using these formulas, let's say if we take this one with our current AP, we have 5 terms, so n is 5, the first term is 1 and the fifth term is 9, the nth term. So the sum 1 plus 3 plus 5 plus 7 plus 9 will be 5 by 2 into 1 plus 9. So 5 by 2 into 10, 25. And look, if you add it up, 1 plus 3, 4, 4 plus 5, 9, 9 plus 7, 16, 16 plus 9, 25. So clearly the formula is working. So like this, just like with the nth term, we have some interesting questions that can come. So let's have a look at them now.
Didn't you just give this example on the black screen as well?
So now let's look at a couple of problems using the sum to n terms formula. I'm again going to write it on top. S of n is equal to n by 2 into 2a plus n minus 1 into d, where n is our number of terms, a is our first term, d is our common difference. First, let's do a straightforward question. We will give you an AP. Let's just take our same AP and we will say find the sum to 10 terms. Let's simply plug into our formula. N is equal to 10, A is equal to 1, common difference we know is equal to 2. So S10 will be equal to 10 by 2 into 2A, which is 2 times 1, plus n minus 1, 10 minus 1 into common difference, which is 2. We can see 10 divided by 2 will become 5. This is 2 into 1, 2, plus this will become 10 minus 1, 9, 9 into 2, 18. So the answer is 5 into 20, which is equal to 100. So we can see that the sum to 10 terms of this particular AP will be 100. As always, you can write it out and see for yourself. Now, let's look at what happens when I ask you to find the number of terms if I give you the sum and the AP. So I will now change the question to be how many terms are required or are needed so that their sum is equal to 100 in the AP, the one we just did, 1, 3, 5, 7, dot, dot, dot. Now we know that the answer to this question is 10, but let's see how we would find it if we don't know it from beforehand. So the idea is they basically want you to find n. They've given you S of n, they've given you your AP, so you have your A, you have your common difference, you need to find n. So we know that this is equal to our sum, n is missing, n by 2 into 2a plus n minus 1 into d, 3 minus 1, 2, is equal to the given sum 100. This implies if I start solving it, n by 2 into 2 plus 2n minus 2, simply multiplying this into the bracket, is equal to 100. We can see 2 minus 2 will become 0. This will simply become n by 2 into 2n upon 2. And that is equal to 100. So we can see I can cancel 2 and 2 and I am left with n square is equal to 100. What does that mean? If I take square root on both sides, it means n is equal to plus minus 10, because we know that there are 2 square roots to every square. But obviously n cannot be negative 10. I can't have negative number of terms. I can have negative terms, but my number of terms can't be negative. That doesn't make any sense. So that means our answer is sum of 10 terms is equal to 100 for this AP. So just like for the nth term, we had to solve linear equations. For sum to n terms, we will have to solve a quadratic equation. Here it was a straightforward quadratic equation, but sometimes after doing all of this work, you might end up with a standard quadratic equation, n square minus 5n plus 20 equal to 0, or whatever. So you will solve for that equation, get your roots and get your answer. This is the major type of problem that comes in sum, and with that you should be ready to face this chapter. So let's move on to the next topic.